Okay, let's do some multiplication with polynomials, and we'll be multiplying in all of these examples by a monomial. That means one term. So let's first start off with some easy ones. Here we have 3x, and we're going to multiply that by 5x. Okay, so 3x times 5x. Here we have the coefficient times a variable times a coefficient times a variable. Now, I'll go ahead and write down the answer here, but we're going to talk about a law of exponent that we reviewed a little while ago, but I want to kind of refresh your memory on this type. What I'm first going to do here is multiply the coefficients together. So 3 times 5, and then I'm going to multiply the exponents. And so that would be, I'm going to use a dot. So 3 times 5 times x times x. And so I'm just kind of writing it out in expanded form here. This would give us 15x squared. Now, so that law of exponent that I was talking about basically states that if you have a variable, let's say x, and we're going to multiply it to another variable, we're going to add up the exponents. So for instance, if this is a 3x to the third power, and then this one is a 2x to the second power, what we're doing is we're taking the x, which is the same in both terms, and we're adding the 3 with the 2. Okay, so x third times x to the second power is going to be the same thing as x to the third plus the second, which would give us x to the fifth power. And the reason that's true is because we could break this up, or like kind of deconstruct it. X to the third is the same thing as x times x times x, and x to the second is going to be x times x. And if we're multiplying those two together, you can see we've got 5 of these x's, and so our exponent is going to reflect that. So whenever you have a term that has the same base that or the same variable that is the same letter, you could do this little trick. Now, we can't do it if, say, this were x cubed times y to the second power. These variables here are not the same, and so we can't just add the exponents. Okay, so that would not work. Now, we can have a problem with an x and y, but we just can't combine them any further. So let's go through a couple of more examples, and we're going to be doing this little trick here. So in the second example, we're going to have 7y squared, and we're going to multiply that to 2y. First, we're going to multiply our coefficients, so 7 times 2 is 14, and then we're going to, it looks like we just have a y squared and a y. So y squared plus 1 is going to give us 14 and y to the third power. Now, if you understand what's going on here, you can skip writing this out, but I just want to make sure you understand that you're adding the exponents. Here's another one. 10x squared and times y cubed times 6x cubed y to the fourth power. So both of these terms have two variables with different exponents, and again we're going to multiply the coefficients first, and then deal with the x, and then deal with the y. So here we have an x squared and an x cubed. 2 plus 3 is 5, so that's going to be x to the fifth power. And now we have the y's. Y cubed times y to the fourth. 3 plus 4 is 7. So 60x to the fifth, y to the seventh. And let's do one more tricky one where we're just multiplying a monomial with a monomial. In this example, we have 2a cubed b, c to the fourth. And we're going to multiply that to 10 a to the fifth power, b squared, and c seventh. So notice that in each term, the variables are the same, the exponents are a little different, so we're going to be doing that adding trick again. But first, before we begin, we want to multiply our coefficients, so that's 120, and a is going to be 3 plus 5 is 8. B, that's a 1 and a 2, so that's going to be 3. And then C is 4 and 7, so C is going to be 11. And so our answer is 120, a to the 8th, b to the 3rd, c to the 11th power. All right, now let's go ahead and multiply a monomial to a binomial. So in this case, we have 6x squared times 2x plus 4. And this is kind of like distributive property. We've done a little distributive property before, so we're just going to continue on. We're going to be multiplying this whole thing to both parts within the parentheses, and that helps us eliminate that grouping symbol. So here we've got 12x cubed plus 24x squared. Okay? Let's do another one. Let's say we have a negative 5x cubed times a negative 6x squared plus 2x. Notice we've got the negative times a negative, so we're going to have a positive 30, and then x cubed, and then the 3 plus the 2 is 5, so that'd be x to the 5th. Now we're multiplying this amount to the positive 2x. So a negative times a positive will give us a negative 10x to the 4th. 3 plus 1 is 4. And let's see, I think I have, let's do a monomial times a trinomial. So in this example, we have 6x, y, z, and we're going to multiply that to 9x plus 6y plus 2z. And it's similar to the one that we did here with the distributive property. We're multiplying this 6 to every part within the parentheses, the grouping. So we got a positive times a positive, that's going to be positive 54x. We've got 2 x's, so that'd be x squared, y, z. This one doesn't have a y or z, so I need to at least have the y and z represented in this term. I'm gonna run out of room. Let me rewrite that down here. So 54x squared y z, and now we're going to go 6 times 6, so that's plus 36. We don't have an x here, but we do have a y, so that'd be y squared and the z. 6 times a positive 2 is plus 12x y z squared. Notice we have a z here and a z there. 2 z's make it a squared z. And notice that we don't have common terms. We can't do any more simplifying because our variables have to have the same exponent when we do that. So, you know, this one, in this term we have an x squared, but we don't have an x squared in these two. Same with the y squared here, it's only visible here, and the z squared is only visible there. So these are not like terms. We would call this the finished answer.